Hi everyone, today we'll be discussing the problem fortune telling. This problem appeared in Codeforces around 770, which was rated for Div 2, and the problem number was B. So the problem goes as follows, that Alice and Bob are practicing fortune telling, and the fortune telling is performed as follows, that we have an array A of size n and it consists of non-negative integers. Those are indexed from 1 to n, and we are given a non-negative number d and we start performing the operations with it. So for each index in the array we could perform the following two operations, that we could replace the current number d with d plus ai, or we could replace it with d XOR ai, where XOR is the bitwise XOR. And so the two of these people, so let's say Alice, he starts with d equal to x and Bob starts with x plus 3. So either of these is guaranteed to reach a number y, and we have to tell which one of these reach this result. So if you haven't already tried this problem, then I would recommend you guys to stop the video over here and give it a shot. For those who would like to continue with the solution or have given it a try, let's move on. So we have Alice who starts with x, and we have Bob who starts with x plus 3. We are given an array and we perform some additions and XORs. So XOR could also alternatively be written as the caret symbol that I'll be using, and we perform some operations with the elements of this array, and all of these are non-negative, and we reach a number y, and we have to tell which one of Alice or Bob is eligible to reach the number y, and it's guaranteed that only one of these could have reached this number y, so we have to tell which one. So that's a problem. So let's start off by discussing a few observations. So let's say that I have two ones and I perform an addition or a XOR operation between these two numbers. So the resultant number can either be 2 or it might be 0. In either of these cases, the LSB is going to be 0. So similarly, if I have 1 0, then I perform an addition or a XOR operation. In either of these cases, the answer is going to be 1. So which means that LSB of the number is going to be 1. So generalizing this idea, so if we have even number of ones, so if the set bits is even, I am basically talking about LSB positions of the elements of array and x. Okay, so if these bits are 1, then the LSB of the number is gonna be 0 irrespective of the operations. And similarly, if it was odd, then LSB would have been 1. Let's take a look at the example once. So let's suppose that I have x equal to 7, and let's suppose I have an array equals 2, and I could possibly take 3, and let's take 5, and the resultant number, let's take this number as say 9. I'm not saying that this test case is going to be correct, but I just want to prove my observation for LSB. By taking this test case, I nowhere say that it is possible to perform these operations and reach 9. I'm not trying to state that, but in the Codeforces contest, it's 100% guaranteed that you will be reaching this result. So let's write the binary representation of these numbers. So I have x as this, and I have the binary representations like this. This is for 2, this is for 3, and this is for 5, and resultant number has to be 9. Okay, so I'm saying that irrespective of what operation you perform between these elements, if you perform either XOR operation or an addition operation, you are guaranteed to have the LSB equal to 1. That means it will be set because the set bits are 1, and these are the only ones that will be affecting these position, and 0 won't. So that is the number 1 observation. And similarly, if it was even, let's suppose this bit over here would have been set and this was equal to 3, then there is no way that you could have performed addition or XOR operation between these elements to set this bit. So yeah, this is the number 1 observation. The second observation is that Alice starts with the number x and Bob starts with the number x plus 3. So let's take an example. So let's say x is equal to 1, then Bob will be starting with x plus 3, which is the number 4. So let's take a look at the binary representation. So this is 1 and this is 4. Bob starts with 3. So if you perform the addition operation, then this bit over here will get toggled here and the carry will move on. So it will result in this number, and say that x equal to 2. So this would be binary representation of 2, and you add 3 to it, then this number will get toggled again to 1 and the carry would move on. So you will result in 5 anyway. But the point here that I am trying to make is that if you start with x and reach a certain result whose LSB is set, then you can't have the, by any means you cannot have LSB equal to set if you start with x plus 3, by the same reason, because if you see over here and toggle this bit, then it is gonna ultimately result in toggling of the result bit at LSB position. So the biggest observation over here is that if you start with the number x and you reach that, so that LSB of the result is on, then it is not possible by any means to reach LSB equal to 1 using x plus 3. It is not possible. Therefore it will have to be 0. Similarly, if you start with x and you reach in a place where LSB of the result is equal to 0, then by no means you can have the same result, and LSB of x plus 3 will have to be 1. So this is the key to solve this operation. Secondly, you can simply avoid the fact that you can perform the addition operation simply by performing the XOR operation. Basically, you can avoid either of these two operations simply by performing one operation out of these two. We can obviously guarantee the LSB of these numbers to be same. So yeah, that's enough of theory to solve this question. Let's jump on to the editor. So I have already copied the sample test cases. Let me bring in my template. So I have a function called solve, which I'll be calling the test cases number of times. So that has been taken care of already. So I'll be writing the code for the test cases. Also, we must have a look at the constraints. And it says that y can go till 10 raised to the power 15. That will exceed the integer boundaries. Therefore, I'll be using only and only one macro, which says has defined ll as long. So I'll be using ll. So already the test cases have been taken care of, and the input format is of form ll. We are given the size of array, the number x, and y the result. So we can input these in the same order. Also, let's create an array. The integer shall not exceed the bound, right? Yeah, since it can go till only 10 raised to the power 9, the integers will work in this case. So let's make the vector as b of size n. Let's take in the input in b, and we put simply input I. Now we can just simply perform XOR between the consecutive elements and check for the LSB. So how we can do that is that we already have stored the result in x, so I'll be manipulating x. Yeah, let's take a temporary variable and then I'll remove it. So I start off by initializing this as x, and let's loop through the vector for int I and b, and I'll be just performing the XOR operation. Temp XOR equal to I, and I can say that if x has its LSB as set, and if this is equal to the y's LSB, y is our result, and we must put parenthesis over here, then the answer will be Bob. Then the answer will be Alice. Else we could say that the answer is Bob. Let's optimize this code a little. We don't need to loop through the vector again. We can do this while taking the input, so we don't actually need a vector. So I'll be looping n times. So I can simply say while n minus minus, I'll take a number as input, and I'll simply perform its XOR with temp. Again, we don't need temp over here as well. We can simply manipulate x since we don't care about it. I should have put temp over here, but anyway, so I can simply just manipulate x over here, x or equal to t, and I'll also change this thing. I'll make the code a little smaller, so I can simply say cout if this condition, then Alice else Bob, and I'll also remove this. Yeah, so this starts from here, and I can also remove the handle from here. So that should take care of parenthesis, I guess. Yeah, let's run on the code. It says Alice, Bob, and Alice, and that is the required input. So let's submit the code. So it's for fortune telling. Let me copy the code and let's try and submit this. So the code got accepted. So yeah, that's it from my side. Thank you all guys for watching this video. Goodbye.